Let's put the theory about vector projections into practice with some examples. Example 1. We have to sketch vectors A and B, where vector A is 2i plus j, vector B is 4i. A just go 2 to the right and 1 up from the origin. This vector will start at the origin, and it's a position vector. This is because the question hasn't told you the starting point, so you assume it's the origin. The same with B. B equals 4i, so that will just be 4 across. The second question says find the vector resolute of A in the direction of B. The second part of the question is crucial. It means we want to break down A into two parts. The vector resolute is the part of A that is along B or parallel to B. So we're going to draw a line from the origin along B, but stop it until you get right under the endpoint of A. This is our vector resolute vector, and we're going to call it U. Remember, U is just some scalar multiple of vector B. We also know that the other component of A will be perpendicular to B. This vector is called vector W. It starts at B and is like our secret tunnel, goes up to the point or the end point of A. We can write W as going back along U, so minus U plus A. If you rearrange this, you'll get A minus U, where U, just sub in, is gamma B. So we have to find out what vector U is, and we start by actually finding out what gamma is first. Once we know gamma, we can easily find U. We use the equation that B dotted with W is equal to 0. This is because B and W are at right angles. If you substitute that W equals A minus gamma B, this is what you get. Now you can feel free to substitute A and B into this equation as it is to get gamma. But a lot of people like rearranging this equation for gamma first. We're going to rearrange for gamma first. So if we expand this equation, we will get B dot A minus gamma B dot B, just by bringing that B inside and dotting where appropriate. If we rearrange, we would take minus gamma B dot B to the right-hand side and then bring the B dot B back to the left-hand side by dividing and end up with something like this. Notice that B dot B is really just the length of B squared. I'm going to put that in now. All right, all we have to do now is find out what B dotted with A is. This is the same as A dotted with B, and we've got to find out what the length of B squared is. B dot A, well, that's just 4i plus 0j. I always write in the 0 if there's no j or I component. That's going to be dotted with 2i plus 1j. So we're going to have 4 times 2 plus 0 times 1. The length of B, well, that will just be the square root of 4 squared. So the length of B squared would just be 4 squared, which is 16. All we have to do is clean up here, and we'll end up that gamma is 8 over 16 or a half. Now refer back to our diagram because that looks pretty good. It does look like vector U is about half the length of vector B. So now we have our scalar, we can figure out what U is. U will be equal to half times vector B, where vector b is just 4i. So half times 4i is just 2i. And that looks about right with what we've drawn in our diagram. Part C. Find the scalar resolute of A in the direction of B. That just means determine whether U is in the same direction as B or the opposite direction of B, and what the length of U is. We know that U is in the same direction, right, as B. So that means my scalar resolute is going to be a positive number. And it is going to be the positive length of U. And that's just what I've written here. So we know we're going to have a positive scalar resolute, and the length of vector U, well, U was 2i. The length of that is 2 squared plus there's no j component, 0 squared, take the square root, and you'll just get 2. That means our scalar resolute is positive this length, or positive 2. Find the vector W. So W is the perpendicular vector to B that goes from B to A, or the end point of vector A. So we know that W is equal to A minus U. And we've put that in a diagram for this exact reason. A was 2i plus j, U was 2i. So then W does indeed equal j. Or to get from vector B to that point A via vector W, you would just go 1 unit up. Lastly, find the length of the shortest distance between B and A. Well, notice the shortest distance between a line and a point will always be the perpendicular distance. We already have the perpendicular vector W. So the shortest path between our line and our point A will just be the length of W. And that will just be 1. When they ask for the length of W, don't worry about any direction here. All right, a big sigh of relief that that one is done.